having one or two good ideas. So I mean, we can discuss like this sort of elements. Firstly, obviously they have included this thing. So okay, now generally what happens is you see something like this. Generally you see something like this, and you have to put t as tan theta, let's say, or you can say theta as tan inverse t. But here actually reciprocal is happening, but it doesn't matter. We still put the same substitute only, and if you put it having one or two good ideas. So I mean, we can discuss like this sort of elements. Firstly, obviously they have included this thing. So okay, now generally what happens is you see something like this. Generally you see something like this, and you have to put t as tan theta, let's say, or you can say theta as tan inverse t. But here actually reciprocal is happening, but it doesn't matter. We still put the same substitute only, and if you put it, you will get something like k is sine inverse 1 by sine 2 theta, right? Because if you had put this, you would have gotten sine inverse sine 2 theta. Now, since we have reciprocal inside the argument of sine inverse, so we'll get 1 by sine 2 theta, which is sine inverse cosec 2 theta. Okay, now very amazing. Tell me one thing, whatever is lying inside my sine inverse should be within what range? Can you tell me that? Basically, the domain of sine inverse, I'm asking.
-1 to 1.
Okay, included or open?
Included.
Okay, so that means cosec 2 theta should be like this, right? Now, can you visualize
-0, right?
What? No. Basically, my cosec x.
I thought cosec theta. Is cosec theta defined for 0?
No. So basically, the range of cosec inverse x is itself -infinity to -1 union 1 to infinity.
Yeah.
Right. So that means what all values can it take? Can you tell me?
None, right? Because this is -1 to 1. So I mean, other than 1 and -1, so 2 values.
Yes. Okay. So 1 and -1. Tell me one thing. If my cosec 2 theta is 1, in that case, wouldn't my k be sine inverse of 1? And would that be pi by 2? Okay.
Yeah.
And when my cosec 2 theta is -1, so my k would be sine inverse of -1. And that is how much?
That is -pi by 2.
Correct. So, but since they have said that the k is some positive value, right? So that means we neglect this one and we take only this one. And what is the greatest integer of pi by 2?
Greatest what?
Integer. What is an integer
1.
less than equal to 2? Yeah, correct. 1. So that means your this thing comes out to be 1. So you're having x minus 1.
Yeah, we can start.
Okay, so it is x minus 1 into x plus alpha minus 1. So my equation is actually x square plus x alpha minus 1 minus alpha minus 1. Correct? Can you cross check? Correct? So now they're saying that it should have integral roots. So there are a lot of ways you can do this. Tell me one thing. It is having integral roots. So should we start with discriminant? See, the x would be, it would be what? Minus b. So that is 1 minus alpha plus minus b square minus 4ac. B square is how much? Alpha square plus 1 minus 2 alpha minus 4ac. A is 1 and c is what? This minus alpha minus 1. So minus alpha minus 1. Correct? Upon 2a. Okay.
Yeah.
Now my x comes out to be 1 minus alpha plus minus alpha square. Okay. Plus 1 minus 2 alpha plus 4 alpha and then plus 4 by 2. So my x is 1 minus alpha plus minus under root of, you can do one thing actually. See, this would become plus 2 alpha. So isn't it alpha plus 1 square plus 4? This 4 by 2. Okay. Tell me one thing. We did this in quadratic equation. So the coefficient of x square is already 1. So that means
Yeah.
this should be a perfect square.
Yeah.
Okay, let this be m square. So now can I write this as 4 as m square minus alpha plus 1 square? So isn't it m plus alpha plus 1 into m minus alpha minus? Is this correct?
Mm.
Huh. Now 4 can be written as what? 4 into 1? 1 into 4?
Yeah. Mhm.
2 into 2? Minus 2 into minus 2? Minus 1 into minus 4? Minus 4 into minus. Any other possibility?
Yeah. Mhm.
What?
No.
So we can do one thing. We can substitute each one of them to each, and you can find the number of values. So let's do it. So let's say this case first. So my m plus alpha plus 1 is 4, and my m minus alpha minus 1 is 1. So my m plus alpha is coming out to be 3, and my m minus alpha is coming out to be 2. So what is my m coming out to be now? Basically, are you, yeah, what is your m coming out from here? You can add them, right? M is not coming out to integer, right? Correct? M should be an integer here. You only find which of these is satisfying so that m is an integer.
Two, right?
2, 2. Okay, you're saying this one. Okay.
Yeah.
M plus alpha plus 1 is 2. M minus alpha minus 1 is 2. So m plus alpha is 1. M minus alpha is 3. If you add them, you will have 2m, which is 4. So m is 2. Now, if my m is 2, then my alpha is minus 1. Okay. Any other one are you getting?
No.
Correct. So, and what is the value of x when your alpha is minus 1? So you can put it here, right? It would be 1 minus alpha plus minus 2 by 2. So that is, you can say 1 minus alpha plus 2 by 2, or you can say 1 minus alpha minus 2 by 2, right? Your alpha is minus 1. So you're getting 2 or 0.
0.
Yeah. So that is your integral solutions, and your alpha is minus 1. So the number of values of alpha that you are getting is only 1. So A is correct.
Yeah. I had gotten this. Basically, my dad read the word integral and he was obsessed with this being in the chapter integration, and I did not want to solve it. It's just very silly. I got the answer though.
Okay.
Yeah,
Okay.
I've just been so exhausted. I didn't want to fight, so I was like, okay, fine.
Okay. Now, from your test,
Practice maths regularly, but still don't improve. Because the same mistakes keep repeating, and no one tracks them. In exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected, and real improvement begins.